Dear students, today I am going to give you the demonstration of determination of FAS potentiometrically. For this, we need some components, devices, chemicals, etc. The first thing is we need this digital potentiometer, and then we need small rubber tube to mix up the solution well as a stirrer and a beaker, and two electrodes we need here. This is a platinum electrode, this is a calomel electrode. These two electrodes we need. And then chemicals like potassium dichromate we require here. It acts as an oxidizing agent in the presence of acidic medium. To provide the acidic medium, we are going to use this dilute sulfuric acid, dilute H2SO4, and this is the ferrous ammonium sulfate, a sample of analyte. So these are some chemicals and equipments we require, along with this small distilled water bottle. So now, first thing is we have to fill the potassium dichromate, this K2Cr2O7, in the burette. This is the burette in which the K2Cr2O7 is filled. 0.5 normal potassium dichromate is filled. Secondly, we have to pipette out 25 ml of the ferrous ammonium sulfate. This is the 25 ml of ferrous ammonium sulfate into this. In order to provide the acidic medium for this potassium dichromate, we have to add this K2H2SO4, that is dilute sulfuric acid, one test tube full. Then we have to immerse the electrodes. Before immersing the electrode, we have to wash or rinse with the distilled water like this. So after rinsing with the distilled water, we have to immerse these two electrodes in the FAS solution along with H2SO4, and also a small rubber tube is inserted which acts as a stirrer to mix up the whole solution well. So these are some experimental setup. After this, we have to connect these two electrodes into the digital potentiometer. We already connected these. Just we have to switch on both of these devices. Here it gives some initial reading. So these are some initial values of potential. This we have to note down here. This is 309, that is 309 is the initial potential value for the FAS before the addition of K2Cr2O7. This is the tabular column in which the volume of K2Cr2O7 is written in the first column. In the second column, we have to note down the reading given by the instrument, that is for the zero addition initial value. Here we have to write 309. So after recording this initial potential value, we have to add the K2Cr2O7 in the increment of 0.5 ml. Now I am adding 0.5 ml of K2Cr2O7. So after mixing it thoroughly, we have to record the potential value. Here it gradually changes from 309 to 322. So for the 0.5 ml, it changes to 322. So like this, continuously we have to add 0.5 ml of K2Cr2O7 in the increment of 0.5, 0.5, 0.5 only each time. After mixing it thoroughly, we have to record these changes. There will be a gradual again increase in the potential values. So how long it increases means here there will be a sudden jump in the equivalence point, maybe in the range of 4.5 to 6 or 6.5, depending upon the volume of the FAS given. Here it changes. So like this, we have to record all the changes and also a sudden jump in the potential values. So here I am going to show you some of the previous values recorded here. At the volume of 5 ml here, there will be a sudden jump. This is called the equivalence point. So 4.5, 395, 5 ml, 755. This is called equivalence point, neutralization point. At this junction, so we will all the FAS gets neutralized by this potassium dichromate. That means the reaction gets ended up here. After getting this jump, let us record 4 or 5 readings, like 1, 2, 3, 4, 5 readings in order to get the graph in accurate manner. So after that, we have to switch off all these instruments and let's go with the calculation part. So calculation, observation is very simple here. Already I have shown the tabular column here. It contains 5 different columns, 1, 2, 3, 4, 5. The first column is volume of potassium dichromate 0 to 7.5 or 10 ml. Second column is potential values. Third column is delta E. Fourth column is delta V. And the fifth column is delta E divided by delta V. So this is what the reading given by the instrument. What about the third column, delta E? How to calculate the delta E? Delta E is the successive changes in the two values of potential value. For example, so 351 minus of 220 is 31. Like this, we have to take the difference of these potential values and we have to write here in the column delta E. Similarly, delta V is the successive difference of the volume. In the increment of 0.5 only, we added the potassium dichromate from the burette, and therefore it is a constant value 0.5 from here to there. And at the end, we have to divide the third column delta E divided by fourth column delta V. We are going to get these kind of values. And so after calculating all these things, we have to plot a graph. The nature of the graph will be like this. This is the word nature of a graph obtained here. So if you plot a graph, volume of any potassium dichromate in the x-axis versus the delta E by delta V in the y-axis, we will get like this. This is called the peak. So we have to record this equivalence point. Maybe here 5 at the volume of 5, we are going to get this equivalence point. By note down this equivalence point, we are going to calculate the amount of FAS, strength of FAS by simple calculation. These are some calculation parts here. The strength of the potassium dichromate is 0.5 normal. Volume of FAS pipetted is 25 ml into this beaker, and volume of potassium dichromate consumed from the graph is 5. Therefore, the strength of the FAS is A into B divided by 25 gives 0.05 normal, 0.01 normal. Using that, we can calculate the weight of FAS. That is previous value multiplied by equivalent weight of FAS, that is 392, and it gives at the end 39.2. So this is for the calculation part, and at the end we have to write the result like this. The strength of the FAS is 0.5 normal. The weight of the FAS in the given sample is 39.2. This is how we have to calculate FAS potentiometrically. Thank you.